right, it's section number 2. Welcome, and we're continuing talking about the atom, and this time we're looking at the atomic mass. We've said that protons and neutrons are the two particles in an atom that contribute significantly to the mass of the atom. So those are the ones that we'll be looking at when we're talking about the atomic mass mainly, right? And the masses of atomic particles are experimentally found to be the following. If you check here, I want to bring your attention to this one. Electrons. One electron gives us, experimentally it was found to be 0.000549 mass units. Okay, but when you check protons, look at the difference. You start with a significant number 1, okay, 1.007276 units, and with neutrons what we have is 1.008665 mass units, and you can see that the neutron is even a bit heavier than the proton, okay, than the proton. But this one, the mass is so insignificant, so we can actually don't even consider it when we're looking at the atomic mass. So basically what gives us the atomic mass are the two particles there, the protons and the neutrons. Okay, now next, atoms of the same element. Now we need to understand this. Atoms of the same element will have the same number of protons. They won't change, but they may have different number of neutrons. Now this means that we may find ourselves having atoms of the same element but having different atomic masses, because the atomic mass is given by what? By the number of protons plus the number of neutrons. Okay, so if the number of neutrons can be different for the same type of atoms, then the mass, the atomic masses may be different for the same, for atoms of the same element. Okay, now moving on this one, when we establish and try get to understand that atoms of the same element may have the same number of protons, which will never change, but may have different number of protons, and yet the atomic mass is found by adding the two, it will mean that the atomic masses may be different. Now, what happens if you have such a situation where, for example, you have atoms of carbon? Here, one atom of carbon, another atom of carbon. This one has got maybe say 7 protons. This one has got 8 protons. But the number of, this one has got 8 neutrons. This one has got 7 neutrons. The number of protons would be the same. Carbon, element number 6, 6 protons, 6 protons. But when you add, you're going to get different mass numbers. Those type of atoms of the same element with different masses, atomic masses, but the same number of protons, we call them isotopes. Okay? So if I were to ask you to define what an isotope is, you will say these are atoms of the same element with the same number of protons but different mass numbers. Those are isotopes. What brings the difference in mass numbers is the difference in the number of the number of neutrons. Okay? Number of neutrons. That's what brings in the difference. Okay, now atomic mass continued. We're looking here at how do they find the mass, the atomic masses of the elements as you see them in the periodic table. What is used is what we call the carbon-12 isotope. This is used as a standard mass. So they find the mass of this isotope. They call it carbon-12, and the carbon-12 here, the 12 simply means that you have got an atomic mass of carbon being 12. And that would mean, because carbon is element number 6, it will mean it also has 6 protons. So it will be 6 plus 6, because the atomic mass is protons plus neutrons, and that gives you 12. But you can have an isotope 6 protons, maybe 7 or 8 neutrons, where you would have here 14 as the mass or atomic mass. So they use this one as a standard, and everything else is measured against it, and therefore that becomes what we call a reference point. If that becomes a reference point and everything is measured against it, then whatever you get as the mass of any atom for any element becomes a relative mass, a relative atomic mass. The word relative means measured against certain standards. So this is the reason why you will be people will talk to you about relative atomic masses for certain atoms. Okay, now quickly let's do this calculation here. Relative molecular mass of sodium carbonate. Look, you would say that the relative molecular mass there will be equal to, for sodium you have got 2 sodiums, 2 off. In the periodic table, sodium is having 23, plus carbon, we will use the 12, plus oxygen, 3 into what? 3 into 16. Okay, you work this out. This is going to be 46 plus 12 plus 3 times 6 is 18. Carry 1, 3 times 1 is 3 plus 1, it's 4, 48. And you add this is 58, 58 plus 48, so 58 plus 48, you've got 16 there, and then you've got 106, so that becomes 106 units, like that. So you don't have the units for relative atomic mass. You can leave it open as 106. It is allowed, or just say U mass units, and that's it. Thank you so much. See you in the next section.